Hey guys, how's everything going? This is JSer. In this video, I'm going to continue looking through the TypeScript handbook. It's about literal types today and union and intersection types. Okay, literal types is very simple. It means that we could use specific string rather than the general string type. So we could say, okay, this ising could only have these three values, right? And also we could use numbers, the real numbers instead of number, the number. The string, and also we could use true or false rather than the boolean. And this is just the literal type is just very simple. Okay, that's it. And let's jump to the union and intersection types. These are very important like types. It means actually simply we could use to translate into or and. Okay, let's take a look at union. Just that we mentioned in literal types, this means that ising could be either is in or is out or ising out. This is just what union type is. Like, here, say function, the second parameter of this function could be either string or number. If we pass in with boolean, of course, it will fail. So yeah, string or number. Unions with common fields. Okay, this is a bird and this is a fish, and we could say get small pet could either return a fish or bird. But for bird, it has fly and lay eggs, but for fish, it has swim and lay eggs. And so we get the pet. This pet could be bird, you see, bird or fish. And bird and pet could lay eggs for both, because these lay eggs both exist in interfaces. But if we call swim, it doesn't exist because pet might be bird. Bird doesn't have swim. So this is not okay. Great. So this is very simple, right? Fish or bird. Discriminating unions. This is very interesting. Okay. So, okay. A common technique for working with unions have a single field which use literal types. Okay, single field, this is state here, which exists in all the types, and use literal types, just the specific values that TypeScript could be using it to infer which type it is. Let's take a jump to the example here. These three types, which has different state, loading, failed, success, and each have different separate fields like code or response. Now we have a type, network state. It could be loading, it could be failed, it could be success, right? And while we're handling it, like logger, we get the state. This is union type for these three states, and we could switch the state, right? State could be these three, right? Okay, let's just open it in here. Okay, so this network state is these three, right? And we say net state dot state. Oh, look, this is already state. Network state. Oh, okay, state dot state. Let's see. This state actually has these three values, right? This either loading or failed or success. But if we got code, actually, this code only exists in network failed state. So if it is this state is network loading state, it doesn't have this code. So TypeScript said, okay, this is not true. You can only say if state equals failed, then state will have code, right? Yeah, it's okay, because if state is failed, it could only be network failed state. So it's together with this code. This is why the TypeScript knows which type it is, right? Okay, so we need to use literal type. Not only if, we could use this discriminating feature in switch. You say switch state, and it's loading. Then let's say state here is, you see that it's network loading state, right? If it is failed, okay, failed, network failed state. Let's see. Yeah, failed state. And the last one is success. It's what is it? It's success state. If defaults, it should never, right? It should be some, not what it is. It's never. Yeah, you see, it couldn't be here. This is already exhaustive. Okay, so this is very interesting. So just the rule is very simple. Use a common field, single field, which is literal types, which you can use to let TypeScript narrow down the possible current value. Very interesting, very cool. Typically, we just add a field with a string, okay, or use numbers, and it's cool. Union exhaustiveness checking. This is what we did just now. Okay, we have this network from cache state. We add a new one, right? This is a new state, so now network state has a new state, and this one doesn't generate errors, right? But there's a problem. Actually, the network from cache state is messed out in the switch case, so we need to avoid this. The problem is the two ways to do this. The first one is return the value. Return the value. Then, if one type is if the last type from cache state is S, then actually this implicitly returns void, right? And the string doesn't work. You can see that the error is what the error is. Hey, give us the error. You see, lacks ending return does not include undefined. We could add undefined here. Not okay. Actually, it should be a void. Yeah. This is not cool. The better one is say, okay, default is, you should say, throw some error here, right? So actually, this one, the last one is, this solution is better. We default, if default comes, we returns error. The error use assert never, because this S actually now is network from cache state. It shouldn't be here, so it should be never. But now we pass in network from cache state to never. So this is an error here. So if there's no this type, it will be fine, because this is never, you see. Never. Okay, never. This function is never called, so there will be no problem. And now there's a new type. Okay, you say there's an extra type we forgot to handle, then this is a problem. Case from cache return something. This is also, now we solve the problem. Okay, so this is for exhaustiveness. So why not we just throw an error here? If we throw an error here, there will be no problem, right? Because when it goes here, there will be actually no type errors, because you say default we do something like this. So it means that all the types are handled. And the only thing that the problem is that some cases not handled. So that's why we should add some if check here to handle the type, right? For the cache state, if we do something like this, it's still this will be run, and TypeScript thinks this is okay. We should mark it as not okay. What is not okay? This should not be called. How do we sure that this should not be called? Then, because it's never, so we pass something to never. Or we could say, throw, but also, let's say, return full equals S. Never. Unreachable code. What does it mean by unreachable? The state actually has from cache. Okay, if we define a variable const full never to s and then return full, this full is not assigned never to never. So this is also okay. If we doesn't have this state, it will be no problem because it's never now. Yeah, never here, never could be returned to any type, and then have this state. Okay, this is not never now. So this is a trick, assigning something to never to warn TypeScript this code should not be handled. Never. Great. Intersection types and so both. It's the opposite of union. So we have this error handling and arts work data, arts data. So actually this intersection type could be used to extract the common part of the multiple interfaces. So we can combine these two up, like arts works data plus this error handling, and generate a new type, artwork response, artist response. Yeah. And so this is actually equals, okay. This equals to, we write them both in artwork data and arts data and remove them. But just they're so they are the same. So we can just extract it up. Okay, so that's all for union and intersection types. It's very interesting, especially about the discriminating unions and the exhaustiveness checking with the usage of never. Hope it helps. See you next time. Bye-bye.